All right, Chapter 3, Question 143. The chloride of an unknown metal is believed to have the formula MCl3. I'm going to write while I talk here. MCl3. MCl3. There we go. All right, a 2.395 gram sample, right? So we know the total mass is that. All right, 2.395 grams. 395 grams. Sample of the compound is found to contain 3.606 times, lost myself, 10 to the negative 2 moles of Cl of chloride. Find the molar mass of this unknown metal M. All right, so formula weight of M. The weight of M. All right, that's what we're looking for here. Okay, so we're actually given quite a bit of information in this. We have the total formula, we have the mass of the sample, and we know how many chlorine atoms are contained in it, and that is a huge help in this case. So the game plan for this problem is first to find the mass that's contributed by this unknown metal M. That's going to be the first thing we do, right? So to do that, we're just going to calculate the mass of these chloride ions that we have here, right? We're going to subtract it from this total mass. That's going to give us a total mass of that metal that's present. Second thing we're going to do is we're going to find the number of moles of that metal that are present, right? We can do that with the stoichiometric ratio given from this formula. And then we can find the formula weight by dividing the mass of this, mass of the metal M that's there, by the number of moles that are there, and that'll give us grams per mole, and then we're laughing. All right, so step 1, mass contributed by M. So this is going to be the difference between the total mass and the mass of these chloride ions, whatever that contributes, right? So from 2.395 grams, we are going to subtract this thing in grams. How are we going to get that in grams? We're going to multiply that by its formula weight. So the moles of chloride times 10 to the negative 2 moles, and we are multiplying that by its formula weight, which is 35.45 grams per mole. There we go. Okay, so that bracket here, let's just do the whole thing in one step. 0.395 minus times 3545 gives 1.1167 grams. There we go. That's how much the mass of the metal is. So we're going to write that up here now that we got it. Mass of M equals 1.1167 grams. Okay, we're doing great. Next, we want the number of moles of M. So the moles we can get from the stoichiometry, right? So moles of M, right, is equal to the moles of chlorine. So that's what we have. Moles of chloride, I should say. And now we're going to put in the stoichiometry, and we're going to arrange it so that the moles of chlorine cancel each other out, right? So you see here we have 3, right, see this little subscript 3 there, 3 chlorine per 1 M. So that means 1 mole of M. That's M per 3 moles of chlorine. Right, so these cancel each other out. That number is going to be this one right here. So we divide this number by 3. All right, so that is 0.3606 divided by 3. And that gives us 1.202 times 10 to the negative 2 moles of M. There we go. We're doing great. Okay, so moles of M. M is 1.202 times 10 to the negative 2. Okay, now last step. Find the quotient between the two, and that gives us the formula weight. Sorry, computer froze there. Okay, let's get some room back. All right. So now formula weight of M equals the moles. Oops, sorry. Grams per mole. So mass of M over moles of M. All right, so we had 1.202 times 10 to the negative 2 moles. Oh, good grief. Sorry, guys, I'm back. 1.1167 grams divided by the number of moles, which is 1.202 times 10 to the negative 2 moles. All right. Sorry about that. And that gives us 92.90, confident to there, grams per mole. And there's our formula weight of M.